completely self-taught, so Evo games in Python, or how I travel through time on user interfaces. This is all up on Cromlin Games at Stoz Valley, if you want it off the GitHub for any particular reason. So, started off with a little game, so we're in the sort of 1990s, nice pixel art, very, very sort of Pokemon-esque, and it was driven by, basically I wanted to prove that a Pokemon-like, that will not get me sued, system could actually have a stable ecosystem. You'd have a certain population of different species, even though they have magical powers. And so I started by having a single mouse, the Ember mouse up in the top left, and I ran off evolutionary chains off that. That was all being done by hand. I was using GraphViz to do the layout of individual image files, and I was using a Reddit subreddit and the comment chain, because it actually follows evolutionary branching quite well, the comment chains there. Parent species chosen randomly, but all I would then do is look at where the subspecies might go and handcrafting it, if you like. And there was 3 sorts of types of improvement. There'd be better powers or better matching the environment, so like better claws for climbing trees or something, and sexual competition as well. So for instance, the glow mouse line up along the top, they were competing with the size of ears at one point. And that went relatively well. It got slightly out of hand. And then I accidentally killed everything. So I quite enjoyed that. It took quite a lot of time. There's a lot of graphics, and it was almost systematic enough to be a program. So that's what I set out to do. So we're going further back in time to the turtle. Most of you might be too young to remember Turtle. So this is using the Tkinter and the Turtle module for Python. It's really nice. It's really fun to play with. If you're teaching someone to program, it's a really good way to get going. I've been using it on my 8-year-old nephew, and he speaks Vietnamese, so it's really easy to use. The animal is done as a sequence of lengths and angles, which matches quite well with DNA strings. It means you can chop and splice between animals if you cut at the right point. And it means that a single small change in an angle will give you a different variant in how the animal looks by quite a large chunk. The mutation was using plus or minus 10% on the angles or the dimensions. Plus or minus 10% means that you can go up from 100, you can go up to 110, but then when you go down again, you go to 99. So you're lower than you originally started, and means that anything that's not selected for slowly withers away, which is quite fitting and quite pleasing. 2 examples of things that were assessed against. The top one is prey bonus. So if it was going to be a prey animal, it did better if it had eyes closer to the side of its head for a wide range of vision. It did better if it had a wide head to get those eyes even further apart. And it did better if it had blunt teeth for eating leaves as opposed to sharp teeth for eating meat. And then the sense eval was another one, and that just basically was 4 different factors that made the senses bigger. So it could get bigger eyes or a bigger nose or both. And you just run it for a few generations. So that was one example of what it was throwing out. That was being done for the prey bonus. So the eyes aren't really changing, but the head is getting wider. Problem was, it was slow. It took about 40 seconds for each one to draw, and you can't really run anything off that. There was a lot of cliff edge fitness issues where it would be optimized, 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 fail. And again, that doesn't actually make for a very smooth progression. It means you get an awful lot of failures. You just get stuck in cul-de-sacs. And it was good for modeling environment checks, but there was no interaction between species. So we're now in the 1970s. This is just text. This is basic level user interface. So all it is you input the number of species you want and the incoming energy. It ignores the environment and it focuses on species interaction. So there's a bunch of different stats for each species, and it's just done on scissors, rock, paper. So for instance, for plants, also known as light eaters, scissors quickly grow to full height, is beaten by rock, which is being an entangling climber, so you get vines going up it, and then paper beats that. So a sample output would be something like that. Light eater is noted quickly growing to full height, etc. didn't work. That was it.